Hello friends, welcome to Quality Icons. I am Murli Krishna and today's video we are going to discuss one of the most critical activities in reinforced concrete construction, reinforcement inspection before concrete pouring or before formwork fixing. Many engineers believe that concrete quality begins when concrete is poured. In reality, concrete quality begins much earlier with proper reinforcement inspection. Once concrete is placed and hardened, reinforcement becomes completely hidden inside the structure. Any mistake made before concreting becomes extremely difficult and expensive, or sometimes impossible to correct. Whether you are a site engineer or QAQC engineer, consultant, contractor, or even a civil engineering student, this video will help you understand the complete reinforcement inspection process followed on professional construction sites. In this video, we will cover practical inspection methods, Indian standard codes, requirements, common site mistakes, acceptance criteria, and professional quality practices used in high-rise building projects or infra projects or industrial projects, anything. Let's begin. Why reinforcement inspection is important? Before learning how to inspect reinforcement, let us first understand why reinforcement inspection is so important. Concrete is very strong in compression, but it is in weak in tension. Please remember this point. Concrete is very strong in compression, but it is weak in tension. Steel reinforcement is provided to resist tensile forces and to ensure the structural stability of beams, slabs, columns, footings, and shear walls. If reinforcement is not placed correctly, the concrete structure may be develop cracks, excessive deflection, corrosion, or even structural failures. For example, imagine a beam designed with four bottom bars. Imagine a beam designed with four bottom bars. If one reinforcement bar is accidentally omitted during construction, the beam loses nearly 25% of its tensile reinforcement. Initially, the beam may appear perfectly normal. However, after months or years, cracks begins to develop, deflection increases, and the overall service life of the structure reduces significantly. That is why reinforcement inspection is one of the most important quality control activities before concrete pouring or shuttering erection. Remember this point statement. Quality is not achieved during concrete pouring. Quality begins with the reinforcement inspection. Steel reinforcement is the backbone of the reinforced concrete. Even high-strength concrete cannot perform properly if reinforcement is incorrectly correct, improperly bent, or wrongly placed. So that is why QAQC engineers must inspect reinforcement at every stage. Remember, concrete can never correct reinforcement mistakes after casting. So, what is the relevant IS codes are required for the reinforcement inspection or reinforcement property, steel properties? If anything else, this is the Indian standard codes. Every quality inspection should be carried out according to approved standards and specifications. For reinforcement works in India, several important IS codes are commonly used. IS 456 provides the general requirements for plain and reinforced cement concrete. IS 1786 high strength reinforcement steel default reinforcement bars. IS 2502 code of practicing for bending and fixing of reinforcement. IS 13920 is followed for a tactile detailing in earthquake resistance structures. I think this is the message on the slide. IS 10262, everyone knows that, provide concrete mixed design requirements that work together with the reinforcement detailing. And SP34, SP34 in Handbook on Concrete Reinforcement and Detailing. Project specifications, approved structural drawings, and bar bending schedules must always be considered along with these IS codes. Never rely only on practical experience. Every inspection should be supported by approved engineering standards. Coming to the pre-inspection checks. What is the pre-inspection checks? Before visiting the reinforcement works physically, the first inspection begins inside the site office. Inside the site office. Never use suspended, superseded drawings. Next, check the approval bar bending schedule, commonly called the BBS. The BBS provides detailed information regarding bar diameter, cutting length, low bending shape, quantity, spacing, lap locations, and reinforcement marks. Also verify that the reinforcement grade mentioned in the drawings matches the material received on the site. For example, if the drawing specifies FE 500D reinforcement 500D reinforcement, but FE 500 bars are supplied, this must immediately be reported to the project engineer before installation. Proper document verification avoids costly mistakes during execution. Ensure latest approved drawings are available at your site. We discuss on the bar burning schedule. Bar marks, diameter, length, shape code, quantity, location. BBS must match structural drawing is must. BBS can define the correct bending, accurate quantity, proper placement, quality assurance. See the photographs. What is the shape code, quantity, how many numbers, length, bar length, diameter, which diameter, 16 mm, 10 mm, 12 mm, anything. Location member, column C1, C2, beam, B1, B2, B3, etc., etc. This is the steel identification. Steel identification is very physical inspection. This is the first. You verify the grade. You verify the grade with as per your drawing. Your drawing shows FE 500D. That will be reflect on the test certificate. FE 500D. See FE 500D. The standard code. Which manufacturer. Which diameter, the heat number, a date of test, what is the chemical compositions, what is the mechanical properties. See this. This is the manufacturing test certificate or mill test certificate. This is supplied by the vendor, producer, steel manufacturer. Ensure steel is approved. Suppose, for example, you are using the Tata Steel or anything else, that steel will approved or not. You can You can ensure the quality assurance department or project planning head department what materials are approved by the project specification. Quality starts with the right material selection, right grade, right diameter, right manufacturer, right heat number, right certificate. Reinforcement steel identification is the one of the part. Reinforcement that is that he or she, this is the tag identification. See, tag number, tag heat number, grade number, size, heat number, batch number, length, weight, manufacturing date, plant, Tata Steel, Kalinganagar, for example. See, steel grade, example, high strength deformed bars, batch number, traceability. Traceability ensures you can trace the steel back to the mill records, mill test certificate, like equivalent to MTC. This is chemical compositions and mechanical properties, yield strength, tensile strength, elongation, bend test, rebend test. All properties are covered in the mill test certificate, physical and mechanical properties. On-site identification checklist. So checklist in the sense check manufacturer's tag on each bundle. Verify grade FE 415, FE 500, FE 500D, FE 550. So anything. Note heat numbers important for the traceability. Match heat number with the MTC. Check ribs pattern and ISI mark. This is the physical verification, guys. Check ribs pattern and ISI mark. Each bar should be imposed on the ISI mark. Ensure steel is free from excessive rust or oil, paint. Tag properly to avoid damage and mixing. What happens if mixed grades are used? Problem. What problem? What happens? Mixed grades are used in that site. Different grades is equal to different strength. Weaker bars may yield early. Poor bond strength, uneven stress distribution, structural cracks and deflections, risk of structural failures. Consequences reduced load carrying capacity, more cracks and corrosion, shorter life of the structure, safety hazard of the building, costly repairs and legal issues. Best practices use one grade of steel in each structural member. Maintain separate stock for each grade. Verify MTC for every heat number. Train site team to read tags and MTCs. It's very important. Trainings is very important for the workforce or the engineers or the supervisors, whoever it will involved in the site activities. Record all details in steel registers. Follow QAQC inspections at every stage. Steel is the backbone of the RCC structure. Right identification today ensures strength and safety for tomorrow. Quality tip. Never assume the grade by color or rib pattern. Always verify with the tag plus heat number plus MTC. This is warning sign. Using wrong or mixed grade steel can compromise the entire structure. So this is the pre-inspection part of the pre-inspection checks. Storage. What is the see how the people are storing and separation tags for identification. This is the very important. Bar should be stored above the ground level. This is very important. That will be stacked on the wooden sleepers or any RCC sleepers. Protect from mud, from free from excessive rust. Separated according to diameter. Proper storage ensures quality steel and stronger structures. Different diameters should be stacked separately with the proper identification. Exposure to standing water should be avoided because continuous moisture accelerates corrosion. Storage areas should remain clean and well organized to avoid mixing of reinforcement sizes. For example, mixing 16 millimeter dia bars with 20 bars can easily lead to incorrect installation. Proper storage improves productivity, minimizes the wastage, and ensures full material traceability. This is the material management area. Quality begins long before concrete is poured. This is also be the part of the pre-inspection check. Cutting machines. This is the tools for the reinforcement cutting, bending using at site. Now let us move to reinforcement processing equipment. The cutting machines plays an important role in maintaining dimensional accuracy. Before starting production, inspect the machine carefully. Ensure that the cutting blades are sharp and free from excessive wear. Verify the machine calibration using a measuring tape. Randomly check the cut lengths against the approved bar bending schedules. Well maintained machines ensure accurate cutting and safe work. Inspect before you cut. Safety, accuracy, quality is most important. For example, if the required cutting length is 3200 mm, 3200 mm, but the machine repeatedly cuts bars shorter by 20 mm, the error will affect the lap lengths. 20 mm, 50 mm, anything else, the effect, the error will affect on lap lengths, anchorage lengths, and reinforcement positioning. This will impact on the placing on the steel, fixing on the steel. Never assume the machine is always accurate. Periodic calibrations and quality checks are essential. Use only approved cutting machines. The safety guards also be very important. Coming to the pre-inspection checks, bending machine also be one of the most important. Bending machine. Cutting of the reinforcement, bars are shaped using bar bending machines. This is called bar bending machines. Incorrect bending is one of the most common quality issues observed on construction sites. Before production begins, inspect the machine rollers, bending pins, and operating conditions. Verify that the bending angle matches the approved bar bending schedule shapes. Common bending angles include 90 degrees, 135 degrees, 135 degrees, and 180 degrees, depending on the structural requirements. For seismic structures, stirrups generally require 135 degrees hooks in accordance with the ductile detailing provisions. Always ensure randomly selected bent bars to verify dimensions. Improper bending not only affects reinforcement placement but also reduces structural performance. Very important. This is very important. Accuracy during accuracy during bending directly contributes to structural integrity. Check before bending, accuracy today, strength forever. So, coming to the part of pre-inspection checks, measuring equipment. Measuring equipment in the sense steel tape, vernier, cover blocks, templates, cover blocks. Measuring equipment, steel tape, vernier, cover blocks, templates are in good condition. Before inspecting reinforcement, every QA/QC engineer should have that right inspection tools. Without proper measuring equipment, inspection becomes an assumption rather than a verification. The basic tools include a measuring tape for checking bar lengths and spacing, a vernier caliper to verify reinforcement diameter, a cover meter or cover gauge for checking concrete cover, a spirit level to verify alignment and approved structural drawings, along with the bar bending schedule. This is very important. Every measurement should be compared with the approved drawings. Every measurement should be compared with the approved drawings only, not with experience, not with your personal experience or my personal experience or memory. For example, if the drawing specifies a spacing of 150 mm, never assume it is correctly by visual inspection. Use a measuring tape and verify with the spacing physically. Don't judge on the physical appearance. Parameter quality inspection is based on the measurements, not assumptions. Clear? Cover. Cover is most important. Sorry, I think cover. I think missing on the cover discussion. One of the most overlooked items during reinforcement inspection is the concrete cover blocks. The concrete cover is the distance between the outer surface of the concrete and the nearest reinforcement bar. This cover protects the reinforcement against corrosion, fire, moisture, and other environmental effects. If the cover is less than the specified value, reinforcement may become exposed after a few years due to carbonation or corrosion. If the cover is excessive, the effective depth of the structural member reduces, which affects its long load carrying capacities. For residential buildings, the cover generally varies depending on the structural member. Footings usually require about 75 mm, columns generally requires 40 mm, 30 mm, beams require approximately 25 to 40 mm, slabs are generally require around 20 mm, 25 mm, unless specified otherwise in the project drawings or specifications. Always use approved concrete cover blocks of the correct size and adequate compressive strength. That is equivalent to whatever you are using the concrete grade, that is equivalent to the same grade use the cover block also. Avoid using broken concrete pieces, bricks, stones, wood bricks, or reinforcement offcuts as spacers. These practices are unacceptable. That is broken concrete pieces, bricks, stones. This is the replacement of the cover blocks. This is not acceptable. These practices are unacceptable and lead to poor quality concrete. Coming to the couplers, just we briefly discussion on the couplers. In modern high-rise construction, reinforcement couplers are increasingly replacing conventional lap splices. A coupler mechanically joins two reinforcement bars, providing continuity without increasing reinforcement congestion. Without increasing reinforcement congestion. The first inspection point is to verify that the coupler type matches the approved drawings and manufacturer specification. Next, ensure that the threaded length is complete and that both reinforcement bars are fully engaged inside the coupler. There should be no partially engaged threads. Always verify the tightening method recommended by the manufacturer. Some couplers require torque tightening, while of others use lock nuts or visual indicators. Random pull-out or tensile testing may also be specified as part of the quality control process. A common site mistake is leaving one reinforcement bar only partially inserted into the coupler. Although the coupler may appear connected externally, the actual load transfer becomes inadequate. Therefore, every coupler should be visually inspected before concreting. Every coupler should be visually inspected before concreting. See, approved manufacturer. Physically, you have as a quality control engineer or site engineer or foreman, anything, uh, anyone. Verify the approved manufacturer, thread quality. That means, as mentioned in your brochures, as mentioned in your specifications, thread. What is the thread shape, V shape or U shape? Test certificates, torque requirement. Quality couplers ensure strong, safe, and reliable connections. Strong connections build strong structures. Simple. Reinforcement. This is manpower, the part of the pre-inspection check. Manpower. Ensure certified bar benders. Ensure certified bar benders are your team workforce. Experienced supervisors. Approved foremen are available. Skilled people ensure accurate bending and better quality. Please remember, skilled people ensure accurate bending and better quality. Right manpower, stronger structures. Quality starts with the right team only. So during cutting and bending inspection, every quality control should continuously monitor, verify the correct cutting length. They are following the correct cutting length. This is very important for all engineers, field engineers or quality engineers or everyone should know the during cutting. After cutting, there is no use, no short bars, no excessive wastage. Minimize the wastage control. No gas cutting unless approved. The cutting length is as per BBS or drawing required. Correct cutting ensure. Small deviations in cutting can lead to major structural issues. Small deviations in cutting can lead to major structural issues. This is also be part of the cutting and bending inspection. Bending. This is for the bending. Bending, correct bend angle, correct hook, correct crank, correct radius. No cracks after bending. What is the bend radius? Can you see the bend radius? Shape code. What is the shape? Correct cranks. As per BBS shape code is this. Wrong shape mismatch. 90 degrees hook, 135 degrees hook, 180 degrees hook, cranks, U shape. Proper bending ensures safety, strength, and durability of the structure. So, rebending. Avoid repeated rebending because steel loses strength after repeated bending. This is never accepted. This is not a good practice also. Rust. If you finding any rust, remove loose rust before fixing. If found any heavy corrosion should not be accepted. Crystal clear this is. If finding the heavy corrosion, that will be that material will be rejected simply. Identification, separate bars according to the draw diameter wise, members, bar mark, bundle to avoid confusions. Identification traceability. A proper bending ensures safety, strength, and durability of the structure. Small neglect today can lead to major structural failures tomorrow. Reinforcement placing inspection. Coming to the reinforcement placing inspection. Avoid repeated bendings. We already earlier we discussed with our the rust we discussed. Identification is must. So in the part of placing, this is the most critical stage. Quality control engineer must verify what is the spacing, what is the diameter, or number of bars. Check bar spacing using measuring tape only. Confirm bar diameter as per drawing. Main bar 16 mm, stirrup 8 mm. The drawing identifications. Number of bars. Count to reinforcement. Missing bars are a major non-conformance. It will be missing bars are a major non-conformance. Reinforcement checkings. Key points. Development length. LD, LD, LD. Check required development length. LD as per IS 446 2000, class number 26.2.1.2. Inadequate development length may lead to bond failures. Lap length. See, this is the lap length. Verify lap lengths as per drawings and IS codes. Avoid lapping at maximum stress zones. Avoid lapping at maximum stress zones. This is very important. Proper lap length ensures full stress transfer. Lap length always ensure full stress transfer to another bar. Anchorage, hook length, anchorage length. Ensure proper hook and anchorage. As per IS 446, class number 26.2.11. Proper anchorage prevents pull-out failure. Proper anchorage prevents pull-out failures. Cover. Measure cover using cover gauge. Ensure minimum cover as per design. Correct cover protects steel from corrosion and fire. Maintain cover as specified in drawings for beam, columns, slabs, footings. Proper cover ensures durability, strength, and long life. Quality reminder. Follow IS codes, drawings, and best practices to ensure safe and durable structures. This is the important slide, lap length details and lapping zones. So lap length formula, LD is equal to pi into sigma S by 4 into tau BD. So pi diameter of the bar, design stress in steel, tau BD design bond stress. This is the formula, lap length, LD. So design bond stress. The values are mentioned in table 26 of IS 446 2000. M20 and above plain bars 1.2 megapascals, deformed bars 2.5 megapascals, M15 1, deformed 2, M10 0.8 1.6, lap length LD multiplies. Compression. These lap lengths are the basic lap length obtained from formula shall be multiplied by the condition. Where the condition? The element, what element the condition is playing on the compression zone, tension zones, top mats, top bars, epoxy coated bars, unlightweighted concrete, cast against ground, seismics as per YS 1893. Use the greater of basic LD or minimum lap length from IS 456. Example of lap length calculations. For example, 16 mm dia. That is grade is Fe 500 in M20 concrete in tension zone. Fe 500 steel given 16 mm dia, bond stress is equal to 0.87 into Fy. Fy is the grade of the steel. So 435 megapascals. That is bond stress tau BD is equal to M20 deformed bars as per the IS 456 2.5 megapascals. LD is equal to 16 into 435 by 4 into 2.5, that is 696 mm. Apply tension multiples 1.3 mm. Required lap length 696 into 1.3 905 mm. Provide LD greater than 905 mm. Provide minimum 50D is equal to 50 into 16 800 mm. Hence provides 905 mm or more. This is the basic funda. So lapping zones in structures, clear visual guide. Don't lap in the middle one third span. This is the LD zone. Beams, lapping zones. Lap at tension zones near supports only. Avoid lap in middle one third spans. Columns. Lap in top and bottom one third heights of columns only. Don't lap in middle one third height. See these figures. This is the slabs, lapping zone. Prefer top in shorter span direction. Prefer top in shorter span direction. This is for the slabs. Don't lap in middle zone of longer spans. Walls, shear walls. Don't edges, lap at edges, boundary elements. Don't lap in middle one third height. This is the general guidelines. Provide laps only where necessary. Stagger laps. Not more than 50% bars lapped at one section. Provide proper anchorage beyond lap lengths. Provide transverse reinforcement in lap zones. Don't lap more than 50% bars at a section. Maintain proper concrete cover. Use mechanical couplers in high congestion areas or where laps are critical. Follow bar bending schedules and drawings. Important notes. Lap length ensures stress transfer from one bar to another. Proper lapping improves safety and structural durability of the structure. Improper laps can lead to slip, cracks, and structural failures. Always follow IS codes and approved drawings. This is the incorrect. There is no maintaining of the staggered position, lapping zone. See, incorrect. Too many laps at one section. This is very wrong practice. Staggered lapping. This is the staggered lapping. See, the first bar is C, the second bar is lapping zone. So not more than 50% bars lapped at one section. Important IS codes: IS 456 2000, IS 16172 2023, mechanical couplers of reinforcement bars, IS 1893 2016, criteria for earthquake resistance designs. Reinforcement, part of the reinforcement checks, key points, chairs and spacer blocks. Chairs and spacer blocks. Reinforcement chairs play a very important role in maintaining the correct level of reinforcement during concrete pouring. Without proper support, reinforcement may settle under its own weight or due to worker movement. This changes the effective depth of the structural member and reduces its structural performance. Chairs should be adequately spaced based on reinforcement diameter and expected construction loads. The chairs themselves should be stable. properly tied, and capable of supporting reinforcement without bending. See, never allow reinforcement to rest directly on the shuttering surface. Proper support ensures that the reinforcement remains exactly where the structural designer intended. Verify approved concrete cover blocks. Approved concrete cover blocks, precast concrete blocks, wheel spacers. This is a PVC, bar chairs, continuous chairs. Use only approved spacers to maintain design cover and structural durability. Never use tiles, wood pieces, bricks, broken concretes. These materials don't provide proper cover and may fail during concreting. Small details in reinforcement lead to big difference in strength and durability. One of the most important point is binding weights. Binding weight. Binding should be tight. Reinforcement is firmly tied and stable. Loose reinforcement shifting during concreting. Tight binding is equal to stable reinforcement, strong structure. Reinforcement is loose and may shift during concreting. So binding wire selection also be very important. Our project specification is mentioned on the 18 gauge or 20 gauge, anything else that should be used on your project. The tying, binding also be very important. Congestion, correct proper spacing. Check concrete can flow properly. Adequate spacing follows concrete to flow and compact properly. Too much congestion causes honeycombing. Too many bars in one area blocks concrete flow and causes honeycombing. Proper spacing is equal to better flow, durability of structure. Proper binding and spacing ensures safety, strength, and durability of the structure. Reinforcement, part of the reinforcement checks, one of the most important key point is insets. That is, verify on the electrical conduits, sleeves, anchor bolts, embedded items before concreting. All inserts must be in correct location, level, and secure. Verify all inserts before concrete. Prevent rework and structural issues. Conduits are in correct location, aligned and securely fixed. Sleeves are fixed, plumb and at correct level. Anchor bolts are correct in position, aligned with securely fixed. Before embedded items, all embedded items are in correct location, levels and securely fixed. Cross check with the surveyor. Recheck all inserts before concreting. Ensure no movement during concreting. Already we discussed about the couplers. Coupler standard code is the IS 16172 2023. Full engagement, alignment, tightening, position. Steel couplers for mechanical splices of reinforcing bars, requirements and test methods is IS 16172 2023. Use approved couplers installed correctly, ensure stronger and safer structure. This is the starter bars. Starter bars in the sense verticality, spacing, projection, projection length. Starter bars must be vertical. Spacing must be as per drawings and design. Projection must be as per drawing and specifications. Incorrect examples to be avoided. Not vertical, poor bonding and load transfer. Many of the sites This is the practical issue, not vertical. The vertical bars, starter bars are not vertical in many locations because of the site issues, practical issues. This is not accepted. Uneven spacing causes congestion and weak sections. Insufficient projection leads to inadequate lap and failures. This will be definitely goes on the structural failure. Inadequate, insufficient projection. Correct starter bars ensure structural continuity and safety of the structure. Please remember it. The structural continuity is based on the correct starter bars. Cleanliness. Ensure reinforcement is free from mud, oil, grease, paint, concrete debris. This was not accepted. Mud or oils, grease. Finally, clean and acceptance is acceptable is need. Reinforcement must be clean, sound, and free from contaminants. Post inspection before concreting. This is general points. Only after all checks concrete pouring should begin. Reinforcement matches drawing. Cover is correct. Bars tied properly. Chase installed. Cover blocks fixed. Couplers. If in case your project is in lapping areas, couplers provided. Couplers are ensured tightened, or that proper tightening and positioning, lapping zones. Insets and insets are completed. Reinforcement cleaned, survey levels checked, engineers approved obtained. Final approval from engineer project in charge is mandatory. Only after all checks concrete pouring should begin. Thorough inspection today prevents defects tomorrow. Common site mistakes. Before we conclude, let's review some of the most common reinforcement mistakes observed on construction sites. Okay, these mistakes may appear small during execution, but they can significantly affect the structural safety, durability, and performance of the structure. The first mistake is using reinforcement of the wrong diameter. For example, replacing a 20 mm diaph 20 mm bar with a 16 mm bar without approval reduces the steel area and directly affects the load carrying capacity. The second mistake is incorrect bar spacing. Closely spaced reinforcement causes congestion and poor concrete compaction, while excessive spacing reduces structural performance. Another common issue is insufficient concrete cover. Without adequate cover, reinforcement becomes vulnerable to corrosion, carbonation, and fire damage. Improper lap locations, missing reinforcement bars, loose binding, damaged cover blocks, bent starter bars, and unauthorized cutting of reinforcement. This is very important, guys. Unauthorized cutting of reinforcement are also be frequently observed during inspections. Every one of these defects is preventable through systematic inspection. Remember, quality is achieved by preventing mistakes, not by repairing them later. Quality is achieved by preventing mistakes, not by repairing them later. Right reinforcement today, stronger structure for tomorrow. This is the equipment tools do's and don'ts. What is the do? Like we are using the cutting machines, bending machines, and couplers. Do's and don'ts. See the image. Use proper Now let's discuss the correct practices for the reinforcement cutting machines. Always inspect the machine before starting work. Ensure that the blades are sharp and securely fixed. Verify machine calibration regularly using a measuring tape. Only trained operators should be use the cutting machines. The cutting area should always be clean and free from unnecessary materials. Workers must wear safety shoes, gloves, helmets, and eye protection. Now let's look at practices that should never be allowed. Never operate a machine with damaged blades. Never cut multiple bars beyond the machine's rated capacity. This is very important. Never measure reinforcement by estimation. Always measure every cutting length according to the approved bar bending schedules. Never allow untrained workers to operate cutting. A small cutting error repeated hundreds of times can lead to major reinforcement shortages and dimensional inaccuracies across the project. So same like that bar bending machines also. The accuracy of bending directly influences the reinforcement placement and structural behavior. Always inspect the bending pins, rollers, electrical systems, and emergency stop controls before starting work. Now let's discuss verify bending angles and hook dimensions against the bar bending schedules. Check the machine is stable and operating smoothly. Now let's discuss with the what should never be done. Never heat reinforcement bars with gas torches makes bending easier unless specifically approved by the engineer. Never straighten and rebend reinforcement repeatedly. Repeated bending weakness the steel and make cause microscopic cracks that are not visible during inspections. Always replace severely damaged reinforcement instead of attempting repairs. Professional reinforcement work depends on precision, not improvisation. So, like couplers. Mechanical couplers have become standard practice in high-rise construction. However, incorrect installation completely defeats their purpose. Always verify that the couplers manufacturers approved for the project. Check the thread condition before installation. Ensure that the reinforcement bars are fully inserted into the coupler. Follow the manufacturer's tightening procedures. Where torque tightening is specified, use calibrated torque wrenches. Maintain complete traceability using heat numbers and inspection records. Now let's discuss unacceptable practices. Never install couplers with damaged or dirty threads. Never leave partially engaged reinforcement inside the coupler. Never mix different manufacturers' components unless specifically approved. Remember, a coupler transfers the entire force from one reinforcement bar to another. Improper installation may result in complete joint failure.